So this is still going to be x1. And so we're going to deal with variables. Okay, the thing to know about square roots or the radical symbol or square roots, only perfect things can leave. So if it's imperfect, it can't leave. With a variable, sometimes variables will leave parts of themselves behind. And so we're going to go through patterns. That's what we just did. And so we're going to use our ability to do patterns to kind of see what would happen. So let's see. So the square root of x is going to equal square root of x. Well, that didn't do very much. So the square root of x squared is going to equal x. Okay, and this is basically the definition of square root. It's the opposite of squared, so hopefully that makes sense. That basically the square root and the squared cancel. But here's where the pattern is going to come in handy. And then we'll probably learn a rule somehow. I keep forgetting to put that on there. I didn't write that right. X to the sixth. I'm going to do one more after this. Okay. So there's my pattern. So go down here and just look at it a little bit and see if you notice anything about the pattern. And what numbers do you think square roots think are perfect? What numbers do you think they don't like so much? And by numbers, in this case, I'm talking about exponents. Okay, I'm looking and like that's an even exponent, right? That's an even exponent. That's an even exponent. It seems to me like the square root likes even exponents. It thinks that they're perfect, and then it spits out like something that is recognizable, right? But look at these odd exponents. What does it do? Okay. The way I like to look at it is it's basically, this is a very, very snobby thing, and so it only produces perfect things, and then it leaves basically the trash or the garbage in a radical. And this is kind of like a remainder. And so I want you to think about old school, elementary school, where you remember remainders? If you don't remember remainder, I'll show you what you used to have to do. So you'd have something like this, and you'd have like 5. How many times does 5 go into 8? Once. What's left? And then you're used to write this. Remember that? That's basically what we're doing, except for the remainder always is going to be radical x. So this is basically the formula. Okay. X, whatever the number is, you just divide it by 2, and that's what it's going to answer. And basically, the remainder is going to be always. I butchered that word. I left out all kinds of letters. You're welcome. Okay, so I'm going to give you a problem and see if you can get it done as I fix that. So let's look at this problem right here. Well, you can just copy that, so I'll just do this. X to the 11th. Let's see if we can figure out what that is. and then I'll show you how to do it. I just left all, this is just so bad. Okay, so what I'm going to do is I'm going to do this. To get it out, I'm just going to do x11 divided by 2. Okay, and we're not going to make this any harder. So what is x divided by 11 divided by 2? It's like 5.5, right? Is that right? Okay, so my answer is going to be x divided by 5. What did I say that's going to happen to your remainder? It's just going to be this, right? So if you get something like this, let's do this one. Let's see what this one is. X to the 12th. Because you're really only going to have two options here. You're either going to have an odd number that's going to have a remainder, or you're going to have an even number. Is an even number going to have a remainder? So this is just x divided by 2. That's just going to be this, right? And it's not getting harder. This is it on this. Okay, I'll actually show you about as hard as it's going to get. Okay, so let's look at this problem right here. And then we'll get a little bit harder and then go. So we need to figure out how to do this on our calculator. So now you get to use your calculators. We're done not using calculators. I can't put this x to the 5th on the calculator. I can only put the 72 in my calculator. So go ahead and put 72 in your calculator and tell me what it shows. And depending on your calculator, I'll tell you what it's going to show you. Wherever I put mine. Because the nice thing is we don't have to do it by hand, although it's nice to know how to do it by hand. Okay, there's two things that this is going to show you. It is either going to show you this. It's not going to show you that ever. It's going to show you this, or it's going to show you something like this. Of course, I rounded that one. I'm going to want this. Your math classes are going to want this. Your science classes are going to want this. Okay, if you have this kind of calculator, it's really nice. And so let's see if I can get the whole calculator in so you can kind of see what I do. Let's autofocus, which is going to be obnoxious on the video, but it's fine for class. All right, autofocus here. So all you got to do to find this, it's 72. So I'm going to hit second. And right here, the opposite of x squared is square root. And so just going to put a little radical symbol, that's what that's called. And I'm just going to type 72 in. And it's going to just give it to me. If you're in science class and you want to switch it, you use this toggle button. Or if your math teacher says, well, I want it in rounded decimal. And sometimes I do want it in rounded decimal depending if what we're doing. Like in a word problem, I don't ever want an answer like this on a word problem. I don't want to know that it's 6 radical 2 feet to the pool. I probably want to hit this button so I can get the decimal. And so I know that it would be 8.49 feet to the pool. We're not worried about word problems today, but this is what we're trying to do. Okay, does everybody understand? Some of the calculators won't do it. This is not the best calculator in the world, but it's really good. You know, obviously there's calculators better, because this one's only like, I think, $16 at this point. If you had a $100 calculator, probably do even more than this. Okay, but this is kind of a nice thing to have. The reason why we always recommend you get your own of these is because you can use this on the ACT test and other testing situations, and it does like all the things that take time. All right, let's try another one and see if you can do it by yourself, and then I'll set you loose on those other problems. And I'll make this one super duper hard. Oh, I didn't finish this problem, did I? I just did this part. What do I do with this? Well, this is where you do the x 5 divided by 2. That's going to be x 2.5, right? So how is this going to relate to this right here? Well, I got a 6 on the outside. I got a 2 on the inside. This x squared is going to go on the outside, right? Perfect things get to leave. Imperfect things have to stay inside the radical place. And so that would be what? Just an x. And that's how the answer is going to look. All right, I'm going to scoot back down so we can get them nice and bigger. All right, so let's look at this one, and we're going to do the same kind of thing, except for I'm going to add an extra letter. Is the extra letter going to make it harder? It's just I have to divide this 1 by 2 as well. So see if you can figure out this one. Your final answer, and of course it's not a lot of work to show. Your final answer is going to have a radical in it. And we got to figure out the perfect things that can be taken out and the imperfect things that need to be left in the radical. Hopefully when you put that in the calculator, or even if you don't put that in the calculator, it's just 44 for 11. To radical 11. So I'm going to put a 2 on the outside. I'm going to put 11 on the inside. Let's look at x. 3 divided by 2 is going to be 1.5, right? What does that mean? We're going to put x. X to the first goes right here. And we're going to put a, the remainder just goes right here. How about y? Right? That's perfect, and so I just put it on the outside and I'm done.